Electron Configuration Practice Worksheet. There are several parts to this worksheet, and I'll go over each one individually. The first set of problems asks for the unabbreviated electron configuration. What it's asking for is something that looks like this. This is from your reading materials. You can see this right here, this one for oxygen, this one for cobalt. These are what electron configurations look like, and they show us not only what electron energy level the electrons are in, but also what sub-level they're in. There are different sub-levels that electrons go into. Now I want you to remember when we did the Bohr models earlier, there were levels that the electrons go into. Remember, the first level can hold 2, second level holds 8, third level holds 8, the fourth level holds up to 18. Remember this? Now what we're doing is we're breaking these levels down into sub-levels. So it's not that each level holds that many in just one orbital like this. There are actually sub-levels within these levels that can hold a certain number of electrons. And if you want to get into the details of how many can be held in each of those sub-levels, it actually shows you on this sheet in your reading that an S level can hold up to 2, P up to 6, D up to 10, and F up to 14, and the different shapes that those sub-levels have. Now what I'm going to do though is just show you how to write them out. And how we write these is to put the elements, electrons, down in order using this chart. Now you've got this chart in your reading material, and you can see, again, it's at the bottom of the page that had these on it, the different electron configuration examples. And on here, what it shows you is how these fill up in order. So notice I have 1s. 1, the first energy level, can hold up to 2 electrons, and they both go in an S sublevel because the S level can hold up to 2. The second energy level, remember, can hold up to 8. 1, 2, 3, 4, 5, 6, 7, 8. But 2 of them are in an S sublevel, and the other 6 of them are in a P sublevel. So there's a 2S level and a 2P level. When I go across over here, I see there's a 3S sublevel that holds 2, and a 3P sublevel that holds 6, and so on. Notice 4S fills up before 3D. This is why these transition metals act so strange, and we can't use that same 1, 2, 3, 4, 5, 6, 7, 8 rule for their number of valence electrons. So let me take you through an example how we would use this to figure out the electron configuration for an element. Let's look at oxygen. If I were to do the electron configuration of oxygen, oxygen has, here is oxygen right here, 8 total electrons. So I'm going to start here because these electron levels always fill up in order. So I'm going to start with 1s is the first electron level, and it can hold up to 2. And it will have both of those filled because I need to get all the way up to 8, and this will fill up first. So 1s, 2. The next energy level I see is 2s. So 2s, and it will also hold 2. 1, 2. So I put a 2 up here. I keep going across. The next thing I see is 2p. 2p. And oxygen is right here. Now 2p will hold up to 6. However, I'm only going to oxygen. So I'm going to start here, and 2p would have 1, 2, 3, 4 electrons in it. So I write 4 because these 4 would get me up to the 8 total that I need. How can you check and make sure you've done this right? Add up these top numbers. 2 plus 2 is 4 plus 4 is 8, which gets me to electron total of 8, which would give me oxygen. Pardon me. So the next thing that we're going to do is look at one that's a little bigger, and that's the example that was given to you here on your reading material was oxygen. So see how I got that 1s2, 2s2, 2p4 by going in order. Now you can see that cobalt, I'll show you this example, cobalt, we're doing the same thing. 1s holds 2, so there's 1s2. 2s holds 2, so 2s2. 2p holds 6, 2p6. I'm still not at cobalt, which is down here at element number 27. So I'm going to keep my finger here so I know I haven't accidentally passed it. So 2p6, and I write it down. 3s2, write it down. 3p6, 4s2, and then I get to 3d, and it could hold up to 10. However, 3d, I go 1, 2, 3, 4, 5, 6, 7, and I'm at cobalt. So the last one will be 3d7. That's how you do the first type of problem on the electron configuration practice worksheet. So for these 5, you'll do the exact same thing that I just did right here. If you'd like instructions for the next part, watch the next video.